Good morning, mathematicians. How y'all doing? I guess we're going to go back to trying to prove that groups of order 120 are not simple. Okay. How y'all doing? And apparently this is going to be hard. So, get ready. Good morning, Casa Kachori. Okay. OneNote. Open it up. Simple Earth, yeah. Or maybe not, because we're trying to prove that not. We're trying to prove that it's not a simple Earth. Okay. So, why can't N5 be 6? Well, hello, Archit. Well, if it were equal to 6, then that means we would have 6 minus 1 times 5 being equal to 25 elements of order 5. Any tea about quiver representations? Would I still love you if you were a worm? No, Leo, I would not. I can say that definitively. I don't care if you break up with me over that. Well, you know what? I'm thinking more on that. Would I still love you if you were a worm? If I knew that that worm was you, and if someone mailed me that worm and was like, this is Leo, you should take care of him. I mean, that's a crazy thing if you think about it. Just knowing that the worm that you have, what about a wombat? Yeah, maybe. Good evening, Shari. When am I getting a haircut? Soon, hopefully. I don't know. Yeah, I need one. Anyways, Boris, about the quiver representations. My research involves quiver representations, believe it or not. So, for all the classical groups, the varieties that I deal with are quiver varieties. All of the varieties that I deal with are quiver varieties, which is basically like a collection of quiver representations. It's like a space of quiver representations. For example, the GLN case, the Vogan varieties that I deal with are all isomorphic to varieties of the form varieties of the following form. So it's a collection of all n tuples of matrices. This is, say, M1, M2, complex numbers, times dot, up to, let's call it M0, M1, up to, M, R minus 1, M, or N minus 1, MN. And so, yeah, and that's it. That's all there is to it. This is Joe Vogan, the Joe Vogan podcast. Oh my god. I kind of want to have an AI take Vogan's papers and then make a video where it's like the background of the Joe Rogan podcast, but then it's David Vogan, and then it's just him explaining his papers. That'd be so good. I'd listen to that. I'd listen to the David Vogan podcast. That's what I'd listen to. Okay, there's more interesting things to say about this, about how the orbits. Actually, okay, there's something. Actually, okay, I'm getting distracted. Now I'm gonna tell you about an interesting problem I'm gonna solve, or would like to solve. We'll get back to Order 120 stuff. What are the international exams or opportunity you can get after high school to get a good exposure in life? Uh, I don't know. I don't know if international exams are going to help you with that. Um, well, it's a pun. David Vogan's the researcher. Leo made a pun about Joe Rogan. Um, I don't know. You should go to university. So I guess the international exams you take are the final exams for your university courses. Good morning, Ken. You're writing on a proof of folklore result claimed on Overflow and got a proof, but it seems Brody made too strong of a claim. You could only prove it for n equals 1. Oh, but for n bigger than 1, you run into quivers. Interesting. You want to... I don't want to like scoop the result from you, but I kind of want to think of... I kind of want to know what question this is. Yes, I use LaTeX for writing math documents. But this comes with a group acting on this variety, which stratifies it into finitely many orbits. And here's how you specify the orbits for every I and j, I less than or equal to j. You specify the number that is the rank of the product of the matrices from xi up to xj. And so all of the possible ranks basically determine the orbits, because you know there's a given maximum on all of these ranks. And so let me show you a certain example. So we can use these things called rank triangles to classify all of the possible orbits. So for example, let's suppose we just had one matrix. It was one matrix long. Well, then we know in this case the matrix has to be... Wait, does it have to be square? No, it doesn't have to be square. But let's say it's m by n. Let's say it's m by n. A single m by n matrix. Joe Rogan is a David Vogan ripoff who can't even do math. Yeah. Ask your advisor if it's too trivial, but if it can't be generalized or is totally useless, then you'll reveal it. Okay. Am I doing professor? No, I'm not a professor, but I am teaching. Do professors make an account in LinkedIn? Not usually, unless they're also in the applied world. Then maybe they'll have a LinkedIn account. But math professors... We're getting back to QM, Ken. Don't worry, I've not lost track of the stack, the order of operations in my head. Technically, before the quantum mechanics series started, we needed... I told Raymond we'd do groups of order 120, which we're not doing right now, but I just need to explain this thing, because Boris brought up quivers. And this is an example of a quiver variety. Okay, so let's let I don't know p be the minimum of m and n, and then so what are the orbits of the group that acts on this variety? Oh yeah, I guess I didn't say what the group is. So the group that acts on this variety is GL M. Sorry, this should be M0 M1. GL M0 times GL M1 times GL M2 times dot 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 up to GL MN. And what is the action? Is G0, G1 up to Gn acts on this tuple x1 up to xn by G1, G0, G1 inverse, G1, G2 inverse, dot 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 up to Gn minus 1 xn Gn inverse. Okay. So in this case, we're just, here we just have pairs of matrices, say A and B, which act on X, conjugating it as such. And so if P is the minimum of these, what are all the possible orbits? Well, the orbits are classified by the rank 0 matrices, the rank 1 matrices, the rank 2 matrices, up to the rank P matrices. Quantum mechanics. Do we get to study for quarks, leviton, Higgs boson, and neutron in it? Yes, you study all of those things in quantum mechanics. Good morning, Raymond. We are doing... I'm trying to do this problem, but I got sidetracked because Boris mentioned quiver representations. Well, Boris mentioned, quiver representations, and I brought up quiver varieties. Okay, so we have orbits according to the rank, right? So, like, if you have a 2x2 matrix, if it's the space of all 2x2 matrices, then what do you have the orbits? You have the orbits of the 0 matrix. You have an orbit given by matrices that are not 0, but whose determinant is 0. And then we have the matrices whose determinant is not equal to 0. Okay. And now, so here's our orbit. We could label the orbits, Ci to be the orbit of the rank I things. Hello, QB. So one thing that's an interesting question to ask is if you take the closure of this orbit in some variety, the question is this singular? And this has importance for like Langlands type stuff, believe it or not. And so it turns out C naught is its own closure. It's just a single point. So this one is smooth. Always. The largest orbit is also always smooth. So in our particular example here, C2 turns out to be the entire space of, say, n by n matrices. So this is smooth. But the closure of C1 in this case, this is the union of C0 and C1. And this is singular at C1. And so actually, more generally, is it possible that one particle can exist in multiple coordinates at the same time? Sort of. I don't know. Yes, kind of. It's complicated. I don't know. It's kind of complicated. Here's what I can tell you. The wave function, you can have a superposition of the wave function describing two particles. And it seems to be in superposition before we make that measurement. You can Google my name. You can Google my name and archive Kristaps Balidus. I'm pretty sure if you look somewhere on my YouTube, you can also find like my academic webpage. There's links to my papers. Yeah, that's fair, Leo. That's fair. So, okay. I'm trying to. I wonder, is there anyone who knows stuff about singularities and algebraic geometry in this chat? Because I'm hoping someone can help me prove some of this. Maybe Arad would know some. Maybe Leo knows something. But, right. So, more generally, so an orbit is defined by what? The conditions of the ranks of these products being equal to some numbers. What happens when you take the closure? Then it becomes the set of all things where rank is at most this. Where rank is at most this. Yeah, Raymond, if you're supposed to know, then that definitely counts. So, here's the thing, is I want to find, most of the time these orbits are singular. Their closures are singular. And I want to prove this. So, let me give you a very special case that I'm interested in. Glad not to see any differential equations today. Okay, well here, let me just to ruin your day, let me just write one down real quick. I think that's the heat equation. Your schooling environment didn't support quantum mechanics? Well, thankfully there's the internet. Do I believe in ether? If you're talking about ether as opposed to Einstein's theory of relativity that was debunked like 100 years ago. So no. Now, right. So here's one thing I'm trying to prove. So I want the variety of all matrices such that the product from x1 up to xn minus 1 is the zero matrix, and x2, the product from x2 up to xn is the zero matrix. And I believe that this should be singular. This is a special case of the kind of orbits that I'm interested in. Hello, Fimno. So, no one, Shari, no one argues about it. No one who knows what they're talking about argues about it. No actually gainfully employed physicists at respectable institutions argue about it. People who don't know what they're talking about on the internet argue about it all the time. But there's no point in listening to them. Xi are matrices, yeah. And so it shouldn't be too bad to like prove that the zero matrix is a singular point, that it satisfies the Jacobian, right? Because you basically, you're just multiplying a bunch of variables together, right? But here's the thing that I'm a little confused about is so my understanding is that if, so call this variety V. If V is reduced, then if Jacobian, vanishes at P, then okay, thanks for not helping, Leo. if the Jacobian vanishes at P, then V is singular at P. Something like this, right? And here's the thing: for the cases that I'm interested in, including in this case, it's very easy to show that the zero matrix satisfies these equations, obviously, and then also satisfies all the equations of the Jacobian. Right? I mean, by which I mean it also satisfies all of the equations that you get by taking all partial derivatives of this. So the question is, the only gap in my proof then right now is how to prove that this is reduced. How to prove that these are, square free equations. Would I recommend to learn from my channel playlist? Well, of course I'm going to recommend to learn from my channel playlist. Well, I don't know. I don't know your educational background. I don't know your educational background, so I don't know if it's the right. I have a bunch of. I recommend it if you look through my playlists and you find topics that are interesting to you. Have I tried localizing? Thanks, Leo. Thanks, Leo. Right, but how do I mean? So how do I do? Even let's just take the simple. Let's say two 2x2 matrices. Or no, I guess it would be three 2x2 matrices would be like the easy case. So I have this equation, and I don't know what are the letters do I hear? Alpha, beta, maybe. How about U, V, S, T? God, I don't know. Right? A x plus bz. Like, how do I prove that the ideal generated by these things is a reduced ideal? XV YT plus WS ZV plus WT. 120 isn't simple, but 60 is? Yes, there is a simple group of order 160, right? A5 is 160. Have I tried giving up and becoming a baker? Several times already. But I fail at giving up, and then I end up doing another math degree. Having too many interests. Well, that's a problem that I have as well. I also have too many interests. I don't know. All I can say about that is just try to force yourself to stay focused. Spend some time learning about other things, but yeah, it's definitely, you got to dig deep sometimes. Okay, so maybe no one has any idea how I do this. These seem like square free equations, right? I mean, I don't know. I don't know. Okay, let's go back to group theory, I guess. Let's go back to group theory. My hoodie is giving no TV signal? What? Excusez-moi. Let's go back to here. Let's do a little Control X. Insert helpful comment about singularities here. Thanks, Raymond. I'll be sure to mention you when I publish the paper for this problem. Oh, because it looks like static. I see what you're saying, Thumna. Yeah, the young kids will not understand your joke anymore. Well, if you truly believe you can't fix that problem, then you can't. And I guess you'll just watch yourself make the same mistakes. Or you could change your mentality and fix that problem. I don't know. Do I have any roadmap in my channel? No. My videos are chaotic. I mean, I have playlists. I have various playlists, but they're all. It's not like a lot of them don't depend on each other. So just find something you're interested in, and see if you can understand it. Okay. And what else was I saying? Yeah. If you understood Fimnel's joke, you're officially an unk. So it's 25 elements of order 5. We know that much. Okay. It would seem like madness to just purely to go through and try and rule out. Actually, it's not so bad. There's only 4 possibilities in each of these other cases. So, like, I should become a motivational speaker instead? Why? Why should I do that? And why instead? I mean, first off, I don't know why I should become a motivational speaker. And then secondly, why would it be instead? Why would I why couldn't I do both? What do I do? Just a pure element count? Yeah, could I go through and let's see. Okay, what if I did so if there was what if there was 40 3-silo subgroups? What if there was 40 3-silo subgroups? Then there would be 40 minus 1 being 39 times 3 being 39 times 3 elements of order I motivated you to quit your bad habits. Well, did you? You said you can't after I after I suggested you do. So, I mean, let me know if you actually change your bad habits. Then maybe I'll reconsider. Maybe tomorrow you should give me a hint, Raymond. I don't know. Probably I should consider some group action stuff, right? Um, well, you need some quantum. Well, you need a basic understanding of quantum mechanics for quantum computing. But obviously, quantum computing depends on quantum mechanics. So, true, there is more money in motivational speaking. I don't know. Should I become a motivational speaker? So what's this? This is 90 plus. Yeah. So we're out of room for elements. So that would be impossible in this case. Okay. So so we could rule out the case of there being 40. Okay. Could there be 10 CeLO 3 subgroups? Probably now, yes, because then that would be 10 minus 1 times 3. That would just be 3 times 9. That would be 27 elements of order 3. So that's not immediately problematic. That's not immediately problematic, but okay. So maybe I'll put a little bubble here for the n5 equals 6 case. Which field of mathematics am I doing? This is algebra right now. This is group theory. Priest has more money to fly in jet. I mean, it depends on the priest, I guess. Right, Raymond, but that doesn't leave room. Actually, I guess that would leave room for one element of order 2. I guess that would leave room for one element of order 2, actually. No, this is group theory. I mean, they all kind of bleed together, but this is group theory, right? So hang on. Oh, I shouldn't have erased all of that. Okay, wait. If it was 40 of order 3, right, then we have 39 times 3, so then it's 90 plus 27, so then that's 117 of order 3. Yeah, but we know that we already have 25 elements of order 5, right? So it's impossible, right? Because then it's 117 plus at least 25 other elements. Now we're over 120. Yeah. Yeah. Have I done real analysis? Yes. Is it worth it to do? I don't know. That depends. It depends. If you like math, yes, it's completely necessary to do real analysis if you want to keep going in pure math. But if you want to open up a store that sells ties for a living, then no, it's not it's not necessary. Have all groups been found already? Ooh, interesting question. What do you mean by that? What do you mean by that? Because what do you mean by that? Have all groups been found? Yeah. What does it mean to find a group? What does it mean to find a group? Because of course there's infinitely many, right? So you could say, have all primes been found? No. I mean, you could also ask, have all even numbers been found? Well, it depends what you mean by that. We have a complete, most people would say we have a complete structural understanding of even numbers, right? All even numbers are of the form 2 times n for n an integer. This is by definition. This is by definition, all even numbers are of this form, right? Of course, we can't physically list all of the even numbers, but I mean, if you hand me an arbitrary number, I can instantly recognize which even number it is, and I can list in order the numbers, so I can sort of give a unique name to an even number. So you might then think, okay, so there's infinitely many groups. There's infinitely many groups. There's infinitely many groups. How would I, what would it mean to find all groups? Well, we could mean that there is some sort of name that we could give to all the groups. For example, finite abelian groups. We know that every finite abelian group up to isomorphism is just isomorphic to a direct sum of, in fact, we can even be more specific. It's isomorphic to a direct sum of abelian groups of this form. Of this form, right? So one could say, in a certain sense, that we know, right? We know all finite abelian groups. So in some sense, they've been found. Again, we can't literally list them all down. We're not going to write all of them down, but we know that finite abelian groups, I mean, it completely classified by this. So somehow, up to isomorphism, we can reduce the structure of an arbitrary finite abelian group down to some sort of much simpler form, right? Yeah. Ken is jumping ahead here and spoiling the plot. Yeah. So, one might wonder, to be honest, real analysis is much better than group theory or even the whole of algebra. Oh, I see what you're saying. Time for a ban. Put user in 5-minute timeout. That's Boom. Boom, boom, boom. I don't accept such slander on this channel. In high school, you had a chapter in math called Principle of Mathematical Induction. That was too unworthy chapter. Well, I don't know what you mean by that. If you're calling induction unworthy, boom, I'm going to put you in a 1 minute timeout. What was your deleted message? Do I also love the history behind the topics and subjects? Yes, I also love the history behind the topics that I study. Yeah. So, yeah. My name is Kristaps Balladus. Okay, so we might ask, we can classify finite abelian groups. Can we classify all finite groups? Arad, you are a little late. If you know things about varieties, I hope that maybe you have some, you would maybe be able to help answer the question. Look at the space. Let's keep things simple. Look at the variety of all pairs of matrices, all pairs of square matrices, such that the product is equal to 0. The zero matrix. Is that variety reduced? And how do I prove it? And then I need to prove it more. I need to prove more general things, which you could see if you go back earlier in stream. Okay. What advice would I give to a kid fresh out of high school? Advice for math? Are you want to pursue math in university? Is that why you're asking? Are you asking about pursuing math in university? Or are you giving, or do you want like general life advice? Stay in school. That's my advice. Or maybe don't go get a job as a plumber. So we can ask ourselves: can we at least classify finite groups? Well, yes to university. Well then, I guess, have you already applied? So you're fresh out of high school. Have you already applied for university then? Are you going to university in the fall? Or are you still applying for university? This is way too long of a topic. I should just make a video on this so that for the future. Maybe that could be today's video. But can we classify groups of order 1 to... That leads us back to the problem that we're trying to solve. Simple groups. We've classified. If you're willing to accept, you're still applying. I see. What advice would I give for someone who's still applying? Well, focus on the basics and getting really, really good at the basics. I know it's very attractive to go read about very fancy things, and I'm not saying don't do that ever. Spend some time on your weekends, evenings, whatever, reading about like very fancy math with cool words that you're interested in. But really try and have a deep understanding of basic things in linear algebra. And I'd say calculus, but let's say real analysis, linear algebra, and real analysis. Really, really try to dig deep into understanding why everything is true. Professional wrestler is actually the best from that list, Captain Finch. That's my recommendation to all young people. Let's get into wrestling professionally. Yeah, all of math is linear algebra. Even the analysis. So, finite groups. What am I saying here? What am I saying? What am I talking about? Anyways, it took 10,000 pages to classify all simple groups. Every group is built out of simple groups. And so you might think, okay, well, we've classified all the simple groups, so shouldn't that lead to a classification of all finite simple groups? Well, it turns out the extension problem is about how you glue two simple groups together to get a new larger group. And so we would like to classify, or more generally, if you just have two groups, what are all the ways that you can glue them together to get a new bigger group? And we expect this to be just totally unsolvable. In fact, if you go Googling, if you go searching, you'll find that there's some overflow. There's some Math Stack Exchange post that talks about, even quantifies how hard this problem is in terms of like NP type problems. I don't know the actual breakdown. So already for finite groups, it is completely hopeless that we will ever be able to name all such groups. It's completely hopeless that we'll ever be able to name such groups. Now, what else is true? I mean, then, so completely hopeless for finite groups. Never mind infinite groups. We generally understand Lie groups, I would say, which are groups with a manifold structure on them. At least we understand the simple Lie groups. Do we know all the ways that those can be glued together? Actually, that's a good question. I don't know the answer to. I would guess no. But in general, and then yes, as Ken mentions, there's also something called presentations of groups. Now, you're not necessarily forced into understanding. You don't have to use presentations to classify all groups. But for example, in general, if you have two group presentations, so it's where you give a list of generators and relations for your group. If someone gives you two group presentations and asks you the question, are these isomorphic? This is unsolvable. By which I mean it's undecidable. It is an undecidable proposition, like Gödel incompleteness theorem level stuff. So in fact, it is so completely hard. It is so impossibly hard to classify groups by their presentations, and we have a very this is a very precise statement. You don't really get Lie groups, only Lie algebras. Well, that's why we invented Lie algebras. It's a fun open question whether almost all finite groups are two groups. Really? Oh, interesting. And we have no idea? Wow. I wonder what current... Yeah. That seems like a hard thing to even try and come up with the statistics on that. That's interesting. Politician, too much politics, yeah. You subscribed a year ago, but you get to interact now live. Yeah. Well, I mean, I've been streaming for close to coming up to a year. Too much geometry with Lie groups. Oh, you trying to get banned for a minute too? You guess by finding it means to completely define their structure or their sequence. Of course, you can't write every one, but you could classify them. Yeah, I mean, in a certain sense, right? So that's why I brought up this analogy of the even numbers, and then that's why I mentioned finite abelian groups. Most people would agree we've classified all finite abelian groups, even though there's infinitely many. But with groups in general, it is like we have pretty precise ways of describing the fact that it is hopeless to ever classify all groups. It is hopeless to even classify all finite groups. What is that notation? No, nothing to do with vectors. I'm not gonna get into this. Is to do with group theory. So, You'll have to wait till you've read some group theory before I can explain that. Gilbert Strang said he was just beginning to truly understand linear algebra. Yeah. Yeah. You know, it'd be a fun reading project. It'd be a fun reading project is the going through the Collingwood and McGovern's book on nilpotent orbits. So the total Jacobian in the first factor is a function of E. Wait, what's E? Is a function of E? Huh? The total Jacobian is a function of E? Why E? So you're saying we have two... So you're... why E? What do you mean by E? But okay. Wait, why E? Why is it that? So we have a pair of matrices AB. At A, but the variety is all pairs, so it doesn't really make sense to have a tangent at A, right? No, phi. Sorry, we're a ways from. It's gonna be a while before we work our way to quantum. Back to quantum. We haven't even finished the subgroup problem, and I'm now way distracted by other things. But the total Jacobian in the first factor. Yeah, because this is the variety of all pairs A and B. So how could we have a tangent vector at A? It should be a tangent vector at A comma B, right? Well, I don't live in the USA, but I live just a little north of the USA. Sure, you might use that notation in alternating current, but yeah, there's a lot of notation in a lot of different places that gets used, and so this kind of notation gets used for all sorts of different things, all sorts of different purposes that don't necessarily have anything to do with each other. You were just looking at the Jacobian of partial derivative with respect to entries of A without B. For a fixed B, it's a submatrix of the full Jacobian. This is a singularity thing where everything blows up and we try to tame it by smoothing down. It is indeed, Captain Finch. Yeah, I still don't understand. So, I mean, what we consider... Yeah, I still don't really understand it, I'll be honest. I mean, what we consider something like A comma B, A plus AB plus epsilon XY or something. No, I don't know. I don't get it. I need to go read some like basic algebraic geometry is what I need to do. Okay. So, okay. 49 minutes. I should probably go. What do I think of backwards engineered proof, where instead of starting from the premise, you work up to the statement? Yeah, it's called reverse mathematics. Seems cool. I've never studied it properly, but it does seem cool to me. Okay, so let's go back here for this. So we've ruled out the case of there being 40 CeLO 3 subgroups. There could maybe be 10. If there were 10, then we would have 27 elements of order 3. And so we would have, as a running track, that would mean 1 plus 25 elements of order 5 plus 27 elements of order 3. So it brings us to 40, 52, 53 elements as a running total. So now, what would that mean? The rest of our elements, of orders. Have I had a chance to go and visit the Large Hadron Collider? No, I am not a physicist. Having the chance to go and visit the Large Hadron Collider is a very rare opportunity for a very select group of people. You don't think geometry? You think geometry doesn't get the title it deserves in math? What? What do you mean? The title it deserves? What title? Huh? Wait, so is this even... This doesn't seem possible. This seems like it would be impossible as well, right? Am I right? So, if there was... can you construct a right isosceles triangle using only squares? So what do you mean? What do you mean by construct it using only squares? Like smaller. The squares are allowed to vary, and you just stack squares together to make it isosceles. Yeah. I still don't know. I still don't know why that means geometry doesn't get the title it deserves. Still not sure what you mean by that. I look a bit different now from the picture on my website on the mountain. Yeah. Hopefully I look better, right? um, right. Have I counted incorrectly? Because if that were true, then the remaining elements would have to be 120 minus 53, which would be oh my god, basic math. 170, 167, right? Yeah, I've gone. Yeah, exactly, Raymond. So, and I don't think I don't think that can be possible either, right? Because all of the other, I don't think that could be possible because each of these other things would be like 15 minus 1 times 2, so that's 14 times 2. That would be 28 elements. Yeah, so it's just not possible. Oh no, sorry, I'm wrong because I'm not counting. There's elements of all those are just all the prime order elements. Oh god, 67. I meant 67. I meant 67. But right, I was forgetting. Of course, there's elements of order 3 times 5, elements of order 15, elements of order 6, all these other things. Yeah, this probably isn't the right approach. Um, this probably isn't the right approach, right? So, oh wait, are you saying sorry? Are you saying I've turned into a robot? uh, uh, right. So there'd be 28 elements. So, well, let's keep going with this. So 67 minus 28, that leaves us, okay, 47, that leaves us a 39. Whoa. 39 elements. 39 elements of all the other non-prime power orders. Is that any reason why it would be problematic? What are we working on? We're trying to prove that there's no simple groups of order 120. Why would that be problematic? A priori, I don't see any reason why it would be, right? Okay, so this probably isn't the right approach. Okay. Whatever. I had to give it a shot. Let's copy and paste again. Take the information we definitely know. Take the information we definitely know. Paste it down here. Right. What does simple imply about the group? Well, simple by definition means there's no non-trivial normal subgroups. So it means that it's not built out of smaller subgroups. That's exactly what it means. Actually, hang on. Let me do this. Oh, it won't give me a square lasso. What a load of bullshit. The amount of hard work and time a student has to give to publish their thesis and validate it. What do you mean? What do you mean about? What are you trying to say about the amount of time and hard work? So here's what we know. I guess what are we gonna do? We could have it act on the set of CELO subgroups or something, right? Like what did we do before? So okay. So let me think about a patent their thesis. Nobody patents their thesis in mathematics. Maybe in applied math. But there's certainly no one's getting paid for their PhD thesis in math. You did a proof for your final research project of undergrad about character theory. Hell yeah. Hell yeah. Hell yeah. We love to hear it. We love to hear it on this channel. I guess it's not that hard to be a poet if you're a mathematician. Maybe. I don't know. Some people have a way with words, others don't. Okay, what are we gonna do though? I'm trying to think about what I did in my short in this case. I mean, we could try acting on the set of CELO subgroups, right? Of 6 CELO subgroups. So, what did I do in my short again? Okay, I think maybe I'll have to watch my short and then we'll come back to this tomorrow. A new insight you had. Tensors are like fully interacting two things to become one. Uh, hmm. I mean, uh, okay. So what? How do you? What do tensors have to do with your lava lamp? I mean, it's true when you combine states in quantum mechanics, you take like the tensor product. Uh, but yeah. Um, where does this insight take you? Can a UG grad? I mean, I suppose it means undergrad grad. So it's a bit of an oxymoron. Uh, can an undergrad publish their thesis? Yes, if it's good enough. But I would say it's not common for that to happen. Like conjugate the subgroups so that the inducing map from your okay, is that your way of giving me an extra hint, Raymond? Conjugate the subgroups. Um, well, I was thinking, yeah. I mean, in the short I made about the CeeLo thing, we did one does something like you choose an element of order 5, and then what? Well, you look at like the I don't know. I forget what I'm doing. And then you look at the cyclic group of order 5 and you have this act on the set of CeeLo 5 subgroups. That was I think that was one way to do it. You don't remember the first step. Okay. Great. That sounded like I was being sarcastic, but it's actually kind of a good thing. Do I receive any job offers besides teaching? Java. I certainly don't. No. Okay, but I'm gonna go. I'll see y'all tomorrow. And Q E